What's up everybody, this is test 1 fall 2023, my most recent exam. I haven't made an exam in a while, so excited about this one. As a reminder, the test is going to be similar to this. There's a group of questions and this is just one of the questions that's chosen, so make sure you not only study this question, maybe watch the older videos. There might be other questions there that weren't on this version of the test. So what does single blind and double blind mean? You know what, I just recorded this video and I forgot to press record, so it took me a long time, but maybe this time it'll go faster. Single blind, the participants don't know which treatment they are receiving, but the researchers do. Double blind, neither the participants nor the researchers know which treatment they are receiving. That's number 1. Number 2, what is a designed experiment? A designed experiment is when a researcher assigns individuals to a certain group, intentionally changing the value of the explanatory variable and then recording the value of the response variable for each group. That is a design experiment. The other important one is this one. It says that it measures the value of the response variable without attempting to influence the value of either the response variable or explanatory variable. Make sure you know what that is. That's called the what? Observational study. But the answer is this one. But those are the two ones that are important. Explain the difference between a population and a sample. A population is the entire group that is being studied, while the sample is a subset of the population that is being studied. Take a look at all 4 of these. This is the right one. For this one, it says to open up 2.123 and create a frequency distribution for days. So what you're going to do on this one is you're going to right click My Lab and Mastering like this. You right click it and press open a new tab. It will open up this, then you'll click that yellow button, which will take you to this. Then you click data sets from your textbook, which will take you to this. Then you go to 2.123 right there, which will take you to the question, and then you do stat, table, frequency, and then you click day, click frequency, and press compute. And that's it, it gives you that. Now, the way you get it in there is kind of cool. You just select it and press Control C. To copy in a Mac, you press Command C. You come over here and then you just actually press Control V. You paste it in and it pastes it in nicely like that. See how nice that is? Now this works for a table. You can just press Control C, Control V. Next question. The following are the rates of return for Facebook stock, which with a first class having a lower class limit of 0 and a class width of 0.5 construct a frequency distribution. So you're going to copy the data, press Control C, go to StatCrunch, and you could create a new data table, say new data table like that. It'll open up a new tab and then you paste it in, and then you go to how do you create a frequency table? You go to table, frequency, click that, frequency. We're going to bin it this time. I think it was 0 and 0.5 for the class width. It was 0.5. Press compute, and there it is. Now this is a table again, so you can press Control C and go over there and paste it in. See, you paste the table. It looks nice when you paste it in, and that's it. The following are incomes of college grads. Create a frequency polygon. This is the hard one. First lower class of 35,000 and a class width of 5,000. So copy the data like this. You just grab it, press Control C, go to StatCrunch. Maybe you can create a new table, maybe you don't. Maybe you just paste it right here on variable 2. Call this whatever, data. I don't know, what was it, incomes? Who knows? What we're gonna do, we said 35,000 and 5,000. We're doing a frequency polygon, so we could do stat table frequency. For a frequency polygon, we first need to create the frequency table. So frequency 35,000 and 5,000, and then we can press compute. We can grab this from here, Control C, and paste it on the second one. Notice how I pasted on the second one. Put 0 here. Here I can call this the frequency. This I can call the midpoints. If you want full credit, you're gonna put the midpoints in. What's the midpoint here? 37,500. You get add 35,000 and 40,000, you get 37,500. For the next one, we're adding 5,000. The class width is 5,000. If I subtract 5,000 from this, I get 32,500. What's the last one? The last one is 72,500, right? So watch this. I have my first one is 32,500 to 72,500. Now, I could create a sequence nicely by going to data, sequence from 32,500 right? 32,500 to 72,500 by 5,000. Now something interesting is going to happen here, something really confusing. I'm going to press compute, and look, it created this. I'm going to press Control X, click here, Control V. I'm going to overwrite all those values, and I'm going to say, what the heck happened? Wait, there should be a 0 here. We were supposed to create an extra, so something interesting. This is going from 40,000 to 45,000. We're missing the class from 45,000 to 50,000. So wait, we should actually have an extra class here. If we cut this, press Control X, press paste right here. There should be a 0 here because you're actually missing the 45,000. I don't know why StatCrunch does this, but I'm not too picky on this if you miss this. But if I press Control X here, press Control B, I guess I would just need to create an extra one. If I add 5,000, it would be 77,500. So the next step, what we're going to do is we're going to go to Graph Chart Column. We're going to click the frequency. Row labels are going to be in midpoints, and plot type, points with connected lines, press compute. There's our frequency polygon. Notice we have the 0 on the right and the 0 on the left. This dot is going all the way down to the x-axis, same here. And that's it, that's a frequency polygon. Now watch this, options, copy, right click, copy image, and that's how a nice way to grab this graph and bring it in. And then just press Control V and you paste it in like that. Okay, question number 7. For this question, can I zoom in so you can see these graphs a little bit better? Ooh, nice. I want you to take note of the second summary statistics. There's 4 summary statistics and 4 graphs. The second summary statistics is the one that's different. All of them are 52 except the second summary statistics. So you need to look at all 4 of these graphs and figure out which one is centered around 62. Look at this one. This one's centered around here. That's like 52. 52 is here. Yep, that's 52. Yep, that's 52. This one, that's 62. So this is it. Part A would be number 2. So number 2 is here, so part A. See how I did that? Now that we've got rid of part A, the A graph, let's look at B, C, and D. And what we're gonna do is we're gonna look at the standard deviation. So the standard deviation is 1.6, 10, and 24. We wanna look at the extremes, 1.6 and 24. So 24 is the biggest standard deviation. Now notice this range of values from -8 to 112, that's the biggest. So that would be 4. This one goes 22 to 82, that's 60. This one goes 47 to 57, that's the smallest. So D is number 1, the smallest range of values with the smallest standard deviation. So D is 1. Where's 1? So D is 1, and then 24, that was B because it's going from -8 to 112. That's the biggest range of values. So B is 4, and that's how you do it. So you're looking at, first you look at the center, and then you look at the smallest standard deviation with the biggest standard deviation, and then you just match them all up. That's it. Professor Kim graded an exam with 9 people in it. She found the average to be 82. That's from the 9 people. She then noticed another exam was in her folder. This exam score was 68. What would the new average be? She doesn't want to like recalculate the average by adding all 10. There's a trick. You can add up all 9 some way. So I want you to think about this. Let me break it down for you. So notice that we want the average of the 10 scores. There's 9 grades that we have the average, and then we have 1 extra score. So we're looking for the average of the 10. The average of 10 is the sum of the 10 divided by 10. How do you find the sum of the 10? Let's break it down like this. Check this out. It's the sum of the 9 plus 68. There is a trick to find the sum of the 9, and that trick is to multiply the average times 9. If you have an average and you have the number, just multiply them together, that gives you the sum. So that's it. The sum of the 9 is 82 times 9 plus 68. If you throw that into Desmos, in fact, in this case, you can actually throw it into Desmos. I want you guys to use Desmos. So if you do, I'll demonstrate. Control C, go over here. If I Control V, if I paste it, it actually worked. I'm surprised it works because of the star. Normally you want to press second 8. You want to get the multiplication. That's how it should be. It works. it works for this case in Desmos. And there you go. The new average is 80.6. Think about this also. 9 people had an average of 82, and I got a lower score of 68. That should bring down the average from 82. It should bring it down. In this case, it did go down because it's 80.6, so that makes sense. Next question. For the histogram, determine whether the mean is greater than, less than, or equal to the median. Sorry that the picture wasn't there, but that's the question. Is the mean greater than the median, smaller than the median, or equal? We know it's not equal because this is skewed left. All you got to remember for this question is wherever it's skewed, that's where the mean goes. The mean chases the tail. This is skewed left, so the mean is going to go to the left, so it's smaller. The mean is smaller. That's why X bar is smaller than M. Remember, X bar stands for the sample mean, M stands for the median. So that's the answer. The average number of home runs per year by a baseball player is 13, with a standard deviation of 4. What are the number of home runs? That would be what? Within 3 standard deviations of the mean. Let's try this. So for this question, it's an empirical rule or Chebychev's question, but please know that there are many versions of these questions. This one is actually not going to use the Chebychev's or empirical rule formulas. This is just a within 3 standard deviations question. So all you have to do is what I have shown on the screen. The lower is just the mean minus 3 times the standard deviation, which is 1. The upper is going to be 13 plus 3 times the standard deviation, which is 25. I'm just testing you on the phrasing within 3 standard deviations of the mean. That's very important to me. I want you to be able to understand what that means. So that's what this question is about. It's just, can you understand that phrase, and do you know how to translate that into math, right? That's what that is. So the answer is between 1 and 25 home runs. That's within 3 standard deviations of the mean. Between 1 and 25 home runs is between 3 standard deviations of the mean. Number 11. For this data, what would you use to estimate the center and dispersion, and why? And then what is your estimate of the center and dispersion? For this question, you're going to make a histogram and see if it's skewed left, skewed right, or symmetric and bell-shaped. If it's symmetric and bell-shaped, you're going to use the mean and the standard deviation to estimate the center and the dispersion. If it's skewed left or skewed right, you're going to use the median and the interquartile range. That's it. So grab the data like this, scroll down, press Control C, go to StatCrunch, and if you want to just paste it anywhere, let me close some things, paste it anywhere like right here, Control V. Now graph histogram, sorry my screen is shifted to the left, but graph histogram, I'm kind of making it work. So variable 6, don't even bin it, just press compute and look at the graph. Well, there you go, there's the graph, it's skewed right. So now we know what to do. Watch this, options, copy, right click, copy image, go to your test, and notice that I already did it. So first, part A, it wants an explanation, so you put the graph in, and then you say, since the data is skewed right, we use the median and interquartile range for the center and dispersion. Technically, I should say respectively, right? Because we have a list of median and interquartile range and center and dispersion. Okay, so that is part A, your explanation on what you would use. We would use the median and the interquartile range because it is what? Skewed. Now part B, it wants the answer, so just go back to where we were, which is right here, and do stat, summary stats, columns, pick variable 6, and then what did we say? Median and interquartile range. So just go to IQR, press Control, then select to get 2 things. Press compute, that's the answer. Remember, this looks like a table, so press Control C, then go to Control V, go back to the test and paste it in like that. If you want, get rid of this space, backspace, like that. And there you go. That's how you do that one. The following are the amounts spent on entertainment by a sample of people. Determine if there are any outliers. Remember to find the fences. For this question, you grab the data and paste it into StatCrunch and find the lower fences and the upper fences. To find the lower fences and the upper fences, what you're gonna do is, I'm gonna paste right here. Go to stats, summary stats, columns, click, what are we at? Spending on entertainment. Okay, I guess I already did this before. I'm gonna go to, what I want are Q1, Q3, and the IQR, those three. That's all I need for this question. So 21 is the Q1, Q3 is 52.5, and the IQR is 31.5. I already did this on Desmos right here. I'll show you how I did it. I typed this in first. Just type that in, Control V, and then what I do is to be kind of nifty, I press Control C and Control V. I paste it in like that. And notice that now it gives me a triangle, so it's not evaluating that anymore. And I type in lower fence equals. That's what I do to get it to look like that. And then for the next one, you do Q1 plus 1.5 times the IQR, right? You plug it in like that, then you get the answer. You could press Control C, come over here, press Control V. For some reason it doesn't work on that one. I don't know why. If it doesn't, just press equals 99.75. That is the upper fence. There are formulas for the upper fence. Make sure you know the formulas. For the lower fence, it's Q1 minus 1.5 times the IQR. For the upper fence, it's Q3 plus 1.5 times the IQR. So there you go. Once you get this stuff, I would show my work in the following way. Say new, just grab that like that, go to the test and paste it in. Notice that I have it pasted in right there, see? Now, once you have that, that's your work. You have to show your work on how you got the lower fence and the upper fence. Then what you're gonna do, I actually screenshotted the data a little bit, and well, let me go back and show you what I did at this point. I did something cool. Oh man, let me move this over a little bit so you can see. Oh, there we go, that's nice. I did data, sort, and then I just clicked, where was it, variable 6, right? I just clicked variable 6 and I pressed compute, and what it did was it sorted the data from smallest to largest, right? Is this the right data? I think so. I don't think so. Maybe not. Maybe I'm in the wrong area. Where was I? I think I was right here, spending on entertainment. So I'm gonna go to data again, sort, and just click spending, right? Spending on entertainment, and then press compute. Now it's sorted the data, so now the smallest values are 7, 8, 9, and 10. Make sure you scroll up to make sure you're at the smallest one. So it's 7, 8, 9, and 10. 1 second. All right, so yeah, Amazon package being delivered. So you have the smallest value, 7, 8, 9, and 10. Now when we looked at Desmos, we had a lower fence of -26. Do we have any values smaller than -26? No, so there's no lower fences on the lower end. Do we have any values bigger than 99.75? Probably. If we go back to that one, wasn't there, right here. If we scroll down to the bottom, look, we got some values here bigger than 99. So we have 2 outliers. I took a screenshot of this. I did something like this, new, just to be super cool. I took a screenshot of that and input it on the tests as my kind of showing my work. Going a little extra, I included that. I even included a table here, a two-way table, or I just did insert table and I clicked like that. See how it inserts a table with 2 cells? So I did that. If you guys want to be fancy, and if you do that, I'll be like, wow, this guy watched my video. I might be impressed and give you, who knows, buy you a matcha. All right, so there you go. That's my answer. All right, next one, question number 13. From the following frequency distribution of ages of males, find the mean age. Round your answer to 3 decimal places. So this is grouped data, you guys. Be careful. I see a lot of people. Also notice that you have a little window here, so it's a numerical answer question. Don't type any words here. Just put a number. For this question, just put a number. Copy this stuff like this, go to StatCrunch, as it says here. It says you should copy and paste this data into StatCrunch. This is grouped data. The number 4 means there's 4 males within that age group, 15 males within that age group, etc., etc. Come back to StatCrunch, paste it anywhere, like right here, anywhere. Press OK. Now you have ages and males. This is grouped data, you guys. Summarized data. Don't make the big mistake of averaging these numbers right here, because this is not regular data, right? Don't average those numbers. So go to data, and then go to what do we do? No, summary stats right here. That's the secret. Grouped data, click here. Summary stats, group data, click that. Bins, ages, counts, males. The counts are the numbers, right? Click consecutive lower limits and give me the mean, and that's it. 36.487. Make sure you round correctly because you don't want to get this answer wrong from rounding wrong. Notice there's a 0 here on the right, so the 7 stays the same, and that's it. Going back to the test, 36.487. Does that make sense? Yeah, it does. Because 54 is the biggest frequency, 36 seems to be correct. That seems to be the center of the data, right? So there you go. Whew. Last question. This is a long question here. My Alliance SCA is going to merge with BSF this week. We put together the data below in order to help us pick the top 35 players. It's hard merging because you lose some friends that you might fight with. Come up with a formula, weighted average, to help you sort the people from strongest to weakest based on off the following data. What I want from you are 3 things: an equation or formula you use to rank the people, a screenshot of your ranking, and give me the top 5 and the bottom 5 of your ranking. And this is the weights that I wanted to do. This table is a little bit messed up. I apologize. This city level is 20%. The BP is 20%. The kills are 30%. The reputation is 10%. Weekly giving is actually supposed to be one word. Weekly giving would be the next one, and then history giving is the next one, and then warplane. I'll try to fix that for the next test, but for my video, I'm gonna actually screenshot this. I'm gonna do new. I'm gonna screenshot this and put this somewhere on the right. Move this over here, and then I'll move it over here for now. And I'm going to go to StatCrunch and show you some stuff. Well, you gotta grab this, right? Grab all this humongous amount of data. Press Control C, and then go to StatCrunch, paste that anywhere. You could do new data table. Well, kind of already did this one right here. Whew, my goodness, this is a lot of work. Let me do new data table. I'll start from scratch with you guys. I'm going to click here, Control V, press OK. Now, we have the names on the left, and we have these different columns of data. This is numerical, 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 and numerical, numerical. This is qualitative. The warplane is qualitative, you guys. There's a bunch of yeses and nos. How do I deal with the qualitative data to incorporate that? And I need a formula. So like my formula could be add up all these numbers, right? And then if this is a yes, maybe put a 1 there, or maybe give it like a 10 or whatever number you want the warplane to be worth, right? But I have these percentages here, right? So I have to add up the city level. It should be worth 20%, right? So we have like a weighted average of like how important are all these things? Well, history giving is the least important because it's the second to last thing right here. History giving, right? History giving is only worth 3%. So that one, but what's the most important? 30%. That would be kills, because this is a war game that I'm playing. Age of Origins, it's a war game. So the kills means that you're active in the game and you're fighting in the game a lot. So you see how we have different percentages. Every variable has its own percentage. So there you go. You know, who was that called me? Yeah, I don't know. Probably frontage. I don't know, spam, you know. So we need to create a formula, and the formula looks like this. I'll show you what the formula was. I created it. It was city level times 20% divided by maximum of city level. That for everything. We do this for all of the variables. We do that for all of the variables. We multiply the variable times the weight, 20%, divided by the maximum of that variable. Because if my city level is 10 and the maximum city level is 20, then I'm at 50% of that power of that for city level, right? The maximum city level is 20, my city level is 10, then I'm at a 0.5. I get a 0.5 times that. If my city level is 20 and the maximum city level is 20, then I'm at 100% on city level. You see that gives you that for every variable. And then the maximum, what's the maximum that I can get if I add all these things? 1, because I have these weights, and these weights, guess what they add to? These weights add to 1, right? all of these weights add to 1. 20, 20, 30, 10, 7, 3, and 10. That is a weight that adds to 1, 100%. So that your maximum score is 1. If you were the maximum on everything, then you would have a 1, 100%. You'd be at 100% power. This is like a power ranking. One issue that I need to talk about is this qualitative variable called warplane. How do I numericalize, how do I enumerate that variable? How do I transform that variable to a number? It's right now it's a word. I want it to be a number. I want the yeses to be ones, the no's to be zeros. Okay, so watch this. I'm going to do this data sort, and I'm just going to click warplane. And this is going to keep everything together, by the way. So notice that xop has a city level of well, let me prove this to you real quick. New, I'm gonna do this because I'm gonna prove this to you, that this sort function is gonna keep everything linked together. You need everything linked together. So when you sort it, just click this. It does it. It works. I'm telling you. Don't click anything up here. Don't click anything up here. Just click warplane, press compute, and voila. We have all the no's. Now where was xop? Where was he? Let me find xop. Was at city level 22. Well, is that 22? That's not xop. Let's just find the word xop. There you go. So notice that xop has a city level of 22, a BP of 234,778, 1285244, 450, 615, 13365, and yes. So everything was kept together. We sorted it while restoring. Well, while not restoring, but while keeping everything together. Now, all I got to do is put a 0 for all these no's. So I want a sequence of how many no's? 23 no's. How can I do that? So data sequence from 0 to 0 by 1, and then we'll do that 23 times. Press compute, and voila. That's all my zeros for all those no's. Look at that. Beautiful. How many yeses do I want? So minus 23, because whatever minus 23. What is 55 minus 23? It's 33, 43, 53. That's 32, I think. 55 minus 23, I think is 32. So I'll do data sequence from 1 to 1 by 1. And I'm going to do 30. Did I say 33? Let's do this. All my ones are right here. I'm gonna go like this, Control X, and then I'm gonna scroll down, press Control V, see if I got it right. Nope, delete that. Boom. There you go. Look at that. All the yeses are worth 1. All of the no's are worth 0. So I'm done. This warplane kind of took care of that, you know. Yeah, let me make these a little bit smaller so that you can kind of see at the end what happens. Alright, so sequence. Let's delete this one. Don't need that one. Now watch this. How do I create the formula? I mean, I have the formula. I'm going to show you how I type it in. So data, compute, expression. A lot of work here. I'm going to do build. And I'm going to go city level. Double click that. Times 0.2. Where was my ranking? Where's my ranking again? Did I lose it? Where was it? It's over here somewhere. Right there. So let me take a screenshot of it. New. Move it over here. Right over there. City level times 0.2 divided by, watch this, max of city level. You can type it or click it, whatever you want to do, plus, and then just do that for everything. BP, but if you want, probably you could just double click it. Times, what's BP, 0.2 divided by max. BP, I typed it, plus kills, I'll double click kills. And I'll say, what are kills worth? I think that was the 0.3 divided by a max of kills, plus reputation. What's reputation worth? 0.1 divided by max of reputation. multiplication, I'm typing it, plus weekly giving, it's just calling it weekly, times 0.07 divided by max of weekly plus history, or what was history giving? I don't know why I did that with the quotes, but time, what's history giving? 0.03 divided by max of, double click history again. And then here, watch, plus, I think it was called sequence, our last, that's the one with the zeros and ones. 10%, 0.1 divided by max of sequence, and hope that you got it right. If not, then you're in trouble. You gotta troubleshoot it. Ha, result is empty. Double, what happened? See if you guys could find the mistake. Sequence times 0.1 divided by max of sequence. Everything is, look at that E. Ooh, look at that. No E, huh? That's the problem? Dang. So sad. You could copy this because you do have to show your formula. You could just do this, Control C, go back to the test and paste it. But I'll show that later. Here are the percentages. So this person is only at 22% power. This person is at 52% power. If I scroll to the bottom, that's 91%. That's me actually, Vito Corleone. I was pretty powerful in the game when we were merging. Not anymore, but what I want to do here is I actually want to do this. Watch, data sort, just click that, descending. Look at that. We already know that that works, but look at that. That's first. 91 is the highest number, then 63, then 58. You see how we have it in order now from biggest to smallest. So I'm number one. Watch, I'm gonna do this. I'm gonna go 55 people, right? That's also my other account, Trinity. And then I'm gonna do this, data sequence, and I'm gonna do from 1 to 55 by 1. Just press compute, and look at that, we have our ranking. Beautiful, beautiful. We have the ranking. Vito Corleone number 1, this person number 2, etc. So answer the questions. I mean, that's a lot of work. You gotta practice this. If this is gonna be on the test, you gotta practice this a lot so you can do this pretty quick. So what I'm gonna do is I'm gonna show you how I pasted all this in for this test. How did I paste it? I said, scroll down. Part A, it wanted the formula that you use. Well, there's my formula. Part B, it wanted like your ranking. Well, there it is. Part C, it wanted your top 5 and bottom 5. All right, guys, good luck on the tests. I'll see you guys in class. Peace.